Hi everyone, this is Dr. Nak. Today, what we're going to go over is modeling with linear functions. In previous section, we learned a lot of things about linear functions. Now in this section, what we're going to be doing is we're going to apply what we have learned to solve the word problems. Now, don't hate immediately. I do remember though, when I was a student, I absolutely hated word problems. Maybe English is my second language, who knows? But for us, we're going to embrace them and we're going to become one with the word problems. With that said, let's go over example number 1. It says, a town's population has been growing linearly. In 2004, the population was 7,200. By 2009, the population had grown to 9,100. Assume this trend continues. So here are the problems. Part A, predict the population in 2013. Second part is identify the year in which the population will reach 17,000. All right, we got this. Okay, so first step is this. I usually underline the important information that's given to us in a word problem. So for this particular problem, I think the year of 2004, the population was 7,200 is important. And also 2009, the population is 9,100. So let me just write that down. So in 2004, what do we got? The population was 7,200. And then 2009, the population was 9,100. Now, what I'm going to do is this. I am a very visual person, so I like to draw a picture or draw a chart just to understand what is going on. Okay, so what are we given? Well, we're given the years and then also the population. So what I'm going to do is let's just pretend that our x-axis is going to be the years, and then the y-axis is going to become the population. And let me jot down what we're given. So we're given that at 2004, the year of 2004, and then the year of 2009. Okay, now let's read the part A. What we want to do is we want to predict the population in 2013, right? So what I'm going to do is I'm going to insert 2013 in our chart. All right, so now let's go with the population part. Now, in 2004, population was 7,200. So let's just pretend this is 7,200. So we are here. Now let's do the same thing for year of 2009. 2009, our population became 9,100. So let's just pretend this is 9,100. So I'm going to plot a dot here. Now, if I read the problem carefully, it says that the population is growing linearly. So that means what? I should be able to connect those two dots and make a straight line out of it. So here's our graph connecting those two dots. Now, let's go with part A. So part A, what does it say? It says that predict the population in 2013. So that means what? So we're going to start at 2013, and what the question's asking you is, what is the corresponding y value when our x value is 2013? Now, if I look at this in terms of an x and y, then I can call this point 2004, comma 7,200. I know those are really big numbers. And the second dot is 2009, comma 9,100. So what the question's asking you is, when x is 2013, what is its corresponding y value? Now, in order to find that y value, first what we need to do is we're going to have to come up with the equation of this line. So let's work on that first, and then we'll deal with the rest of it later. All right, so let's go with the equation of the line that's connecting those two dots, which is this one and this one. So first, the key ingredient is the slope. So the slope is y2 minus y1 all over x2 minus x1. So I'm just going to take 9100 and then minus 7200, whole thing divided by 2009 minus 2004. Feel free to use your calculator if your brain is tired already. Anyways, so this is going to be 1900 all over 5. Now that goes in, right? 5 goes into 1900 how many times? 380? Okay, so let me just keep this as our slope. Okay, all right, so now since we're not given the y-intercept, right, I cannot just straight out and bust out the slope-intercept form, which is y equals to mx plus b. So what we're going to do is we're going to use our point-slope form of the equation of the line. So I'm going to write everything out, point-slope. So that goes y minus y1 equals to m quantity x minus x1. Okay, so again, it does not matter which ordered pair that you want to take. So let me just take 2004 and then 7200 as our point. So this is going to be our x1. This is going to be our y1. All right, so plug and chug. So ready? So you're going to have y minus 7200. This is all going to equal to 380 multiplying here by x minus 2004. So from here, we're going to do the same thing as what we did in the last section. We're going to solve for y. So first, let me distribute the 380. Do not freak out because the numbers are a little bit bigger than what you're used to be seeing. So you can do it. So we got y minus 7200 equals 380x and then minus, oh boy, what is that? I got 761520 with my trusty calculator. All right, so then what we're going to do now is we're going to add 7200 on both sides. Okay, so then what do we get? We're going to have y equals 380x, oh yikes, minus, what is that? 754,320. At least that's what I got. Let me box that because this is, I claim that this is going to be our equation of that line above. Now let's not forget what we're computing here. So great, so our equation of this line is y equals 380x minus 754,320. Yikes. Okay, now remember what we're trying to find. So basically what we're going to try to find is that when x is 2013, what is its corresponding y value, right? So what do you think we need to do to find the y value? Right, so here's our y equals. Now what we need to do now is we need to replace this x with our year 2013. Then boom, there's your answer. So let's do it. So we got, let me see, y equals 380 times 2013 and then minus, oh goodness, 754,320. Type that in your trusty calculator. Then what I got was 10,620. All right, so what does it mean? Most important thing is you need to understand what you're trying to compute. Okay, so what we just concluded is that at the year of 2013, our corresponding y value is going to be 10,620, which is same thing as at the year of 2013, we're going to predict that our population is going to be 10,620, and that's what you just computed. So what I wrote was we predict that the population in 2013 will be 10,620. And that's our answer for part A. Now let's talk about part B. So let's read it again. It says identify the year in which the population will reach 17,000. Okay, so first of all, our population is nothing but our y-axis and the year is represented by the x-axis, right? So population will reach 17,000. So let me just jot down where the 17,000 will be. So let me just pretend this is 17,000. So basically what the question's asking is this. What year, right? So what's the value of x when y value is 17,000? Does that make sense? Because again, population are nothing but the y values, and the years are represented by the x values. So basically this is telling you when y is 17,000, what is the corresponding value for x? So where I put the question mark is what we're looking for. So guess what we're gonna do? We have our equation of a line to be y equals 380x minus 754,320, right? So basically what we're going to do is we're going to set our y value to be 17,000 and we're going to solve for x. And that x will give you the year when the population hits 17,000. So let's do it. Okay, so what I did here was I just copy and pasted the picture that we drew along with the equation of that line that we came up with. All right, so now let's take it from here. So when y is 17,000, what is the corresponding x value? All right, so from here, all we need to do is just solve for x. So first, let me bring this crazy amount of number on the left-hand side by adding it. Am I copying this right? 4, 3, 2, 0. All right, so now please get your trusty calculator and add those two numbers. What did you get? I got 771,000 and then 320. That's a big number. Equals 380x. Now dividing by 380 on both sides. Let me just go divided by 380. All right, so then what do we get? So that implies that our x is approximately 2029.789-ish. That's what I got on my calculator. So what does it tell you? Basically, this is telling you that the population will reach 1,700 in between 2029 and 2030. So let's write our answer. So therefore, the population will reach 17,000 between the years of 2029 and 2030. And that is going to be our official answer. Let me just box that. And that was it for example 1. All right, so now let's take a look at the next example. Example 2. You and Dr. Nak start at the same intersection. You walk east at 4 miles per hour, while Dr. Nak walks south at 3 miles per hour. We are communicating with a two-way radio that has a range of 2 miles. How long after we start walking will we fall out of radio connect? All right, so let's first underline the important information. So let me see. You are a speed demon, so because you're going to be walking east at 4 miles per hour. And I am so slow that I'm going to walk south at 3 miles per hour. And another important information is that the two-way radio that has a range of 2 miles. So let me just underline range of 2 miles. Okay, so now let's reread what the question's asking. How long after we start walking will we fall out of radio connect? So since the radio has a range of 2 miles, right? Do you see that basically what this question's asking us to do is how long would it take for us to be 2 miles apart. All right, before we do anything, you know me by now, I need to draw a picture. Check this out. Okay, so pretend that this is the intersection that the problem states. We're going to start at the same intersection, and you are moving, walking towards east at 4 miles per hour. So let me just write that out. Miles per hour. And then I am traveling down south at 3 miles per hour. And that gray rectangular things are supposed to be the two-way radios. Yes, I know. Please do not be jealous of my artistic talent. But anyways, so now let's just recall what the question was asking, right? So how long is it going to take for us to be 2 miles apart? So the blue dots here represents the distance between you and I. And again, the question is, how long does it take for us to be 2 miles apart? Now, since the question's asking us how long, so it depends on time, correct? That's what we're looking for. So let's just assume that at the intersection, our time is at 0. So now I think we can digest the problem better. So basically what the question's asking you is this. What is the value of t such that if your rate is 4 miles per hour and if my rate is at 3 miles per hour, this distance here is going to be 2. So if I have to draw a picture for that, right? Basically what you're asking is, what is this t value when this distance here is 2? Now what else are we given? Well, we're given your rate of change. Your rate of change is 4 miles per hour. And my rate of change is 3 miles per hour. So first, let's denote. I'm going to say let t be the time in hours. All right. And let's make your rate of change, I'm going to make you into a function of time now. All right. So here, let me just go with y stands for u. U of t is nothing but 4 times t. It becomes a function of t because depending on how long you walked, right, this whole distance is going to be totally different. So y of t denotes the distance of how far you traveled with the rate of 4 miles per hour. So this whole output is nothing but a distance at a certain time t. Now I'm going to do the same thing for myself. So let's go with N stands for knock. Knock of t is 3 times t. Does that make sense? So think about it. So when t equals to 2, right? Let's just say t equals to 2. How far did I travel? So if I replace 2, so N of 2 equals 3 times 2, which is 6 miles. So suppose this part, this dot right here is t equals to 2, then the distance from t equals to 0 to t equals to 2 is 6 miles. Now let me label the pictures a little bit differently now. Now, since we just came up with a nice function where it describes how far we traveled in terms of a distance, so that means what? This part here is going to be your y of t, and then this portion is going to be n of t. All right. Now, let me call the distance between us to be d of t. And I just inserted this statement here. So y of t and n of t represent the total distance traveled at time t. So again, it's a function of t because depending on what time it is, do you see that your whole distance is going to be different? When t equals to 2, maybe you could be here. T equals to 4, you could be over here, right? Anyways, keep that in mind, and let's look at another relationship that we've learned. Now, since you're moving towards the east and then I'm going south, there is a 90-degree angle is formed at the intersection. So yes, we can apply the Pythagorean theorem here. And let's not forget what we're trying to find, right? Remember, you want to find the value of t when this whole distance, which is d of t, equals to 2. So please keep that in mind. All right, let's apply the Pythagorean theorem. So what we're going to get is y of t squared plus n of t squared equals to d of t squared, where the y of t was 4t and then n of t was 3t, remember? So let's plug and chug. Ready? So you're going to have y of t squared, so you're going to have 4t squared plus n of t squared, so this is 3t squared equals d of t squared. Now let's compute this. So we're going to have 16t squared and then plus 3 squared is 9. 9t squared equals d of t whole thing squared. Let me just make this a little bit easier on our eyes. Let me just bring the d of t squared on the left hand side. So I'm going to have d of t squared equals, now I'm going to add the 16t squared and 9t squared to get 25t squared. Now, how do you solve for d of t? Yes, you're going to have to take the square root on both sides, but be careful. When you take the square root on both sides, what's going to happen is this. On the right hand side, you're going to have a plus or minus the square root of 25t squared. So let me just do that. So taking the square root, let me see. We'll just write it like this. Square root and then square root. So on the next step, you better have d of t equals to plus or minus the square root of 25t squared. All right, so which is same thing as plus or minus. Now, remember this property from algebra. If you have a square root of a times b, this is square root of a times the square root of b. So here, if I have 25t squared, this is same thing as square root of 25 and then square root of t squared, which is 5t. So here we're going to have plus or minus 5t. But notice that we don't want the negative 5t because we want our total distance to be positive. So here I'm going to write it as, so therefore we're just going to keep the positive part of 5t. So d of t equals just the 5t. Now let me box that because this is a very important information. Now don't forget what we're trying to compute, right? Let's go over this again. So what we want is value of t such that d of t equals to 2. So I just wrote this. What we want is value of t when d of t equals to 2. So do you see that when d of t equals to 2, then I can replace this d of t with the 2. But that means what? 2 better equal to 5t, correct? So that way we can solve for that t. So let's do it. So our d of t is 2. Let me just write d of t equals to 2. So that implies that we're going to have 2 equals to 5t. Now dividing by 5, what do we get? We're going to have t equals to 2 over 5, which is 0.4. Let me box that because that's going to be our final answer, but let's just understand what we just computed. All right, so what we just computed was this. We were able to find the value of t. Our t is 0.4 hours. Let me just write that out. So this is in terms of hours. When the distance between us is going to become 2 miles. Now, if you want to convert 0.4 hours in terms of a minute, then all you have to do is take 60, because there are 60 minutes, right? 60 minutes multiplying here by 0.4, which is going to give us 24 minutes. So what we just found out is this. We're both going to have to walk 24 minutes each. Then after 24 minutes, we're going to lose our connection or the reception of the two-way radio. And that's what we just computed. So here's our official answer. The radio will disconnect after 24 minutes. This problem took us a while to do because we had to think a lot. But look, we did it. All right, let's keep it coming. All right, so example 3. it says there is a straight road from Oceanside to Carlsbad, 25 miles east and 9 miles north. Partway down this road, it junctions with a second road, perpendicular to the first, leading to the town of Vista. If the town of Vista is located 10 miles directly east of the town of Oceanside, how far is the road junction from Oceanside? I know, you're probably sitting and going, say what? I felt exactly the same thing. I sat there, I was like, say what? What's going on? So guess what we're gonna do first? Yes, we're gonna draw a picture. All right, so let's start from Oceanside. Okay, so it says that there is a straight road from Oceanside to Carlsbad, 25 miles east. So let's go 25 miles east and then 9 miles north. So let's pretend this is 9 miles north. So there is Carlsbad. So now since there's supposed to be a straight road, so there you go. Now let's understand the second sentence here. It says partway down this road. So we're talking about this road. It junctions with the second road, perpendicular to the first. So first is this one, leading to the town of Vista. So that means that somewhere along here, right, there's going to be another road that's going to be perpendicular to this road. So what the problem is stating that this portion here, this part right here, is going to be the city of Vista. And please pretend that this circle lies along this horizontal line at the bottom. Second sentence done. Let's go with the third one. It says, if the town of Vista is located 10 miles directly east of the town of Oceanside. That's basically telling us that the distance from Oceanside to Vista is 10 miles. And here comes the question. How far is the road junction from Oceanside? So road junction that they're talking about is here. This is your road junction, and they're asking you what is the distance from Oceanside to this new junction. So here's the picture for it. All right, so now we're ready to go. There's a lot of things going on, but look at it. I mean, overall, do you see a big triangle? I do. So what I'm going to do is this. Let's put this on the XY plane. Okay, so let's take a look at this graph. So what I did was I just centered Oceanside at the origin, which is 0, 0. All right, and then here's Vista. So, but we already know the distance from here to here is 10. So Vista's coordinate is nothing but 10, 0. Now let's go with the Carlsbad. So notice that our Carlsbad, you know what I mean. The Carlsbad, how long do we travel? 25, x is 25, and then y is 9. So the coordinate at the Carlsbad is x is 25, and then y is 9. Now let's deal with the junction. So our junction is going to intersect this line right here in 90-degree angle because it's perpendicular, right? So yes, I know that our junction is right here, but let me extend that. Now notice that these two lines are intersecting at the junction. And we just learned how to compute the intersection between two lines. Also, look at it. Since these two lines are perpendicular, their slope must be the negative reciprocal of each other. So if I can find the slope of the purple line, then if I take the negative reciprocal of his slope, then I should be able to write an equation of a line for the orange one. And from there, we should be able to compute the total distance that we're looking for from Oceanside to the new junction. All right, so now let's get to work. So let's first find an equation of the line that's connecting Oceanside to Carlsbad. So, and again, key ingredient is the slope, right? So let me just write this in purple so that way you can follow which line that I'm talking about. So from Oceanside to Carlsbad, I'm just going to leave it as Carl. All right, so let's first go with the slope, right? So notice that we have 2 points, 0, 0, and then 25, 9. All right, so let's call this one x1, y1, x2, y2. All right, so then our slope is going to be 9 minus 0 over 25 minus 0, which is 9 over 25. Let me box that. Now, since we already know that our y-intercept is 0, so we can use the slope-intercept form to write an equation of this line. So we have y-intercept, which is b equals to 0, and we should be able to write a slope-intercept form, which is of the form y equals mx plus b. But since we're going to have two functions going on, let's just give it a name. So the oceanside to Carlsbad, let me just call it as Carlsbad of x, c of x, equals 9 over 25x, and then plus 0. So simply the equation of the oceanside to Carlsbad line is denoted by c of x equals 9 over 25x. So let me box this. All right, looking good. So what we just discovered is that equation of this line is c of x, instead of f of x, we just have a c of x, is 9 over 25x. All right, so now let's talk about the orange line here. Now again, this orange line is perpendicular to the purple line. So which means that the slope of the orange line must be the negative reciprocal of 9 over 25, which is going to be negative 25 over 9. Let me work this out on the next page. Okay, so I just copy and pasted what we had before. So let's go. Let's work on the orange curve, which is going to connect from Vista to the junction that we're talking about. All right, so this is from Vista to junction. I'll just call it junk. Okay, so since the slope of the purple line is 9 over 25, so let me just write that out. So slope of the purple curve is 9 over 25. So that means that the new slope, the perpendicular slope, must be negative 25 over 9. All right, so keep that in mind. So what do we got going on? So let me just copy this down. So our slope of the orange line has to be negative 25 over 9. And passing through the point, this point here, but we don't know what that point is, but it's certainly passing through 10, 0. All right, so with that said, I think we can write the point slope form of the equation of the line. So let's go. So we have y minus y1 equals to m, and then x minus x1. All right, so in this case, our 10 plays the role of x1, and then your y1 is going to be 0. So plug and chug. So we got y minus 0 equals negative 25 over 9 times x minus 10. Now let's clean up a little bit. So I'm going to distribute the negative 25 over 9 to each term. So to get y equals negative 25 over 9 x, and then plus 250 over 9. But I don't want to call it y equals, so let's name this function. So this is going to go to Vista to junction. So what do you all want to call it? Junction of x maybe? So let's just call it junction of x equals negative 25 over 9x, and then plus 250 over 9. Great, so what we got here is, let's call it j of x, junction of x equals negative 25 over 9x, and then plus 250, oh no, over 9. I'm running out of room. Hopefully you can see that. All right, so next thing that what we need to do is this. Remember what we're doing, right? We're trying to compute the distance from here to here. So that will be helpful. It will be helpful for us if I know where these two lines intersect. What's the coordinate? What's the x value and what's the y value at this points of intersection? So do you remember how to find the points of intersection? Yes, you're going to have to set c of x equals j of x, and then you're going to solve for x. So let's do it. So I'm going to write everything out. So next we want to find the point of intersection of j of x and c of x. All right, so let's do it. So here j of x equals c of x. That implies that negative 25 over 9x plus 250 over 9 equals 9 over 25x. All right, so now let's try to solve for x. So what I would do is I would add 25 over 9x to both sides. And what do we get here? So here what we're going to get is 250 over 9 equals 9 over 25x plus 25 over 9x. Now to add these two, we need a common denominator. So what's the least common denominator? That's 225, I think. So here, let me just bring this over here. Sorry about this mess. So here we're going to have 250 over 9 equals. So I want to write 9 over 25 as an equivalent fraction with the 225 on the bottom. And then we're going to do the same thing for the second fraction, which is 25 over 9. But we want to write the denominator in terms of 225. So what we need to do is that we need to multiply the top and the bottom of 9 over 25 by 9 over 9. So that will give us 225 on the bottom. And here I'm going to multiply top and bottom by 25. So what we're going to get is 9 times 9 is 81. Don't forget the x. And then you're going to have 25 times 25, that's 625. 625 and then x. Now adding those two together, what we're going to get is 250 over 9 equals, what is that? 81 plus 625 is 706. 706 over 225 and then x. Do not freak out because numbers are not looking cute. All right, we got this. So now remember what we're doing. We're trying to solve for x. So what you need to do is you have to multiply by the reciprocal of 706 over 225 to both sides. So here what we're going to do is we're going to multiply by 225 over 706 and multiply this guy by 225. Oh gosh, that's 225 over 706. Sorry. I hope you can see that okay. Now let's take out the clean piece of paper and let's work this on the next page. Okay, so here we are. Okay, so now all we have to do is multiply those crazy looking numbers together to solve for x. Now using my trusty calculator, when I multiply the left hand side of the equation, I have 3,125 all over 353. And this whole thing is going to equal to x. So let me box that. I know, such a nasty number. All right, so now what we need to do is this. Great, we got the x coordinate of the points of intersection. Now what we need to do is we have to find the y coordinate where the two lines meet. Now to do that, you can either take c of x or j of x. Pick the one that looks cute, much cuter or much simpler. So to me, our c of x looks much simpler than I'm going to pick j of x. C of x, which was 9 over 25x. All right, so now let's compute the corresponding y value when x is 3,125 over 353. So that's same thing as 9 over 25, multiplying that by the same number that we just wrote. Oh my goodness. All right, so now let's compute that. On the top, I got 28125. And for the denominator, I got 8,825. Can I simplify that? Let's try. I think this is all going to be 1125 after you simplify it. Whole thing divided by 353. Okay, so that means that the two lines meet, or I should say intersect, at x is 3,125 over 353, and then corresponding y value is 1,125 over 353. Yikes. Okay, so let me just box this because this is another important information. Now let me bring that picture back. Here it is. Now what we just discovered is that this point here is that crazy number. Do I need to write that? Yeah, let's just write it. 3125 over 353, comma, 1125 over 353. Now, since we want to find the distance from Oceanside to this junction, right? Let's look at it. Isn't this nothing but a right triangle here? So, in order to find the distance, as long as if I know the distance of the hypotenuse, which we do, right? Because hypotenuse is 10, and if I know the distance from Vista to this junction here, then I can use the Pythagorean theorem to compute what we want. All right, so what I did was I just picked that triangle and then just rewrote it, but standing up in a different way. Now, since this is 90 degrees, now don't forget, this is the length that what we're looking for. And this is our hypotenuse, which is here. And then the bottom one is the distance from Vista to junction. Now, we already know that the distance from Oceanside to Vista is 10, so the length of the hypotenuse is going to be 10. Now the question is this: how can I find the distance from Vista to our junction? So we're gonna have to bring back our good old distance formula. About this point, you're completely over this problem, but we're almost there. So let's finish it strong. Okay, so our distance formula goes like this. Distance equals square root of quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So let's just call this 10 to be x1, 0 is y1, and the x-coordinate of the points of intersection, let's just call it x2 and then y2. Okay, we got this. So what do we get? Our distance is going to be square root of x2, which is 10, minus x1, which is, oh yikes, 3125 over 353 squared, and then plus y2, which is 1125 over 353, and then minus 0 squared. Okay, so let me just bring it over here. So that means that our distance is going to be, use your trusty calculator. I got the first parentheses is 405 over 353. So now I need to square that. And then plus 1125 over 353 squared. And we're going to take the square root of the whole darn thing. So if I computed it correctly, then what I got was the square root of, oh goodness, 4050 over 353 in the square root. All right, now let's take the square root of this crazy looking number to get an approximate decimal value. I got, this is approximately 3.387. Okay, so I'm just gonna leave it like that. All right, so let me box this. So what we just discovered is that our base, the length of our base right here is approximately 3.387. All right, now I think we're good to go. So now what we're gonna do is we're gonna bust out the Pythagorean theorem and we're done. So let's go. So we have, let me see, let me just call this the question mark to be x maybe. All right, so the formula goes x squared plus 3.387 0.387 squared equals to 10 squared, right? That's the Pythagorean theorem. So here, get your calculator out again. So you're going to have x squared plus 11.47 equals 10 squared is 100. So that means that our x squared is 100 and then minus 11.47. So that's x squared equals 88.53. Now when you remember what you're doing, we're trying to solve for x, but if you're going to solve for x, you have the square root on both sides. But when you do that, on the right hand side, you're going to have a plus and minus. But we're talking about the distance, so just take the positive side of the square root. So that implies that our x is going to be square root of 88.53. So type that in the calculator. And I got this to be approximately 9.41. Oh my goodness, look at it. We are almost done. Actually, we're pretty much done. Okay, so we have found the length of our x, which is 9.41-ish. So I'll put approximately. So this is also approximate. All right, let's continue on. So what we found is that, remember this picture, right? And what we wanted was the distance from the ocean side to the junction. So what we just discovered is that the ocean side to the new junction is approximately 9.41 miles. Finishing off with the sentence, the distance from the ocean side to junction is approximately 9.41 miles. Yay, we did it! Good job, y'all. All right, so far so good. I know it's exhausting, but let's just do another one. This will be the last example that we're going to go over for this section. All right, so let's read it. Dr. Knox is choosing between two car rental companies. The first, Enterprise, charges an upfront fee of $20, then 59 cents per mile. The second, Hertz, charges an upfront fee of $16, then 63 cents a mile. When will Enterprise be the better choice for Dr. Knox? All right, now let's jot down what's important. So Enterprise upfront fee is 20, then 59 cents per mile. And Hertz upfront fee is $16, then 63 cents a mile. Now, this whole problem depends on how far I'm going to be driving. So the distance matter. So let us first denote D be the distance driven in miles. Now, since the cost depends on how far I've driven, which means that the cost depends on D. So what we're going to do now is we're going to try to come up with a function of D, which represents a distance. So let's try to come up with a function of D that's going to denote how much it is going to be. So for the Enterprise, I'm going to say E of D be the cost for renting from Enterprise. And we're going to do the similar thing for Hertz. So Hertz, let's just denote it by H of D. H stands for Hertz, is the cost for renting from Hertz in dollars. Now let's talk about the upfront fee. Now upfront fee means that I have not even driven the car yet, which basically means that when the distance is 0, cost of renting from Enterprise is going to be 20. Same thing for the Hertz, right? Upfront fee means that I have not driven, so the D should be 0. And then H of D denotes the cost for renting from Hertz, right? So here, this is what I would write. Upfront fee is denoted by E of 0. Now, Enterprise upfront fee was $20, right? So let me just write it as 20. And Hertz at the distance of 0 is, how much was it? $16. Now that's taken care of. Now let's talk about the 59 cents per mile and 63 cents a mile. Now those are nothing but rate of change, isn't it? So the rate of change for E of D is nothing but, this is in terms of a dollar, so it's going to be 59 cents per mile. And we could do the same thing for h of d. So the total cost from hertz is, how much was it? 63 cents. So same thing as $0.63 per mile. Now, let's think about what is the same meaning of rate of change in terms of graphing. Wasn't it the slope? Rate of change was nothing but the slope of the line. So let me write that out. All right, so what have we got so far? So we have our slope, and then let's look at the upfront fee, right? So this is when d is 0, y is 20, or e of 0 is 20. So isn't this nothing but a definition of the y-intercept? Think of, e of x equals y equals e of x or something like that. When x is 0, then corresponding value of e of 0 is going to be 20, right? So this is same thing as 0, 20. So this is, as in terms of an ordered pair, this is same thing as 0, 20, which is nothing but your y-intercept. And same thing here, this translates to when x is 0, but in this case, it's d, because d is going to play the role of the x-axis. But anyways, so we're going to have 0, 16. So these are the y-intercepts for the two equations of the line that we're about to find out. So let me write that. Okay, now we got the slope and we got the y-intercept. So we can bust out the slope-intercept form. All right, so let's do that. So I'm going to write it as, therefore, the equation of e of d and h of d are denoted by e of d equals, remember this form, y equals to mx plus b. This is what we're going to follow, right? But instead of an x, we're going to have a variable d. So here what we're going to get is m, which is the slope, 0.59 d, and then plus the y-intercept. Well, y-intercept is at 20. So I'm going to write that as 20. All right, and we're going to do the same thing for h of d. Now, h of d, in terms of mx plus b, well, our x is now, the notation for x is d. So here what we're going to get is 0.63d, and then plus the y-intercept, which is going to be 16. Great. So we got equations of two lines now. Now let's graph this out and see what's going on. All right, so here is the graph. So what I did was I graphed out E of D, which is the total cost by enterprise, and H of D, which is the total cost from hertz. So for the blue curve, that's going to be our E of D. Notice that our y-intercept is at 20. And for H of D, our y-intercept starts at 16. I know this is so close together, but this is the best I can do. Now, let's not forget what we're trying to compute. What is the question asking us to do? When will enterprise be the better choice for Dr. Knock? So what does that mean? What does it mean to be a better choice, right? So do you see that when enterprise cost is lower than hertz, then that is a better choice for me. So that sentence pretty much translates to, when will enterprise become cheaper than hertz? Now, mathematically, remember enterprise price is denoted by E of D, and the hertz price is denoted by H of D. So to translate, when will enterprise become cheaper than hertz, that means that in mathematical term, when does E of D become less than or equal to H of D? Again, this means that when does enterprise cost is going to be less than hertz cost. So let's examine the graph a little bit. So I know it's really hard to see, I apologize. So the blue line is our enterprise cost line. So right now, at the very beginning, notice that the enterprise cost is a little bit more than hertz, which is denoted by the green line, right? So basically what we need to find out is this. When does that blue line going to be below the green line? So basically what we're looking for is the points of intersection between these two lines. So we're going to have to find the points of intersection where the blue line is going to be lower than green. So where would that be? Like, I can't see. I know this is kind of hard to see, but I assume like maybe around here. That's my guess. So anyways, let me just pretend that this is the points of intersection, and let's just call this x comma y equals to what? So this is what we're looking for. Now, to find the points of intersection, remember what we need to do. We need to set the two equations equal to each other, and in this case, we want to find the value of d. Then we should be able to compute the corresponding cost, which is going to be the y value. All right, so let's do it. So here, if I have E of d equals to h of d, then we're going to have 0.59d plus 20 equals 0.63d and then plus 16. Now let me subtract 0.59d from both sides. And what do we get? We're going to have 20 equals 0.63 minus 0.59. So what is that? 0.04 times d plus 16. All right, now remember you're trying to solve for d, so I'm going to subtract 16 from both sides. And then here what we're going to get is 4 equals 0.04d. Now dividing by 0.04 on both sides, you can get your calculator out. Then we get, what do we get? D equals 100. All right, so that means that enterprise price will be cheaper if I drive more than 100 miles. So that will be the value of d here. Sorry, I wrote x first and I put d over it, so it looks really ugly, so I just rewrote it, d comma y. Pretend this is just x comma y. So our distance is 100. Now, although the question does not ask how much do I need to pay at the distance of 100. Now, if you're asked to compute that, all you have to do is replace your d with 100. Then that should give you the value at 100 miles. So let's just do it. So when d is 100, here you're going to have a 59 plus 20, so it's 79. So at this point, I have to pay enterprise $79. But that's not what the question's asking. But anyways, let's just write down the final answer. So here it is. Enterprise will be a better choice for Dr. Nak if she drives more than 100 miles. How you all doing? So we went through 4 examples in great details. I just did not want to skip any steps. Great job. If you did all 4 examples with me, you are a champ. You're amazing. And you see, math is actually applicable to real life situation. Anyways, I'm going to stop here. So good job, y'all, and keep up the good work.